Wassalam ala Rasulullah. So we're all welcome back to the class. And we, inshallah, are going to be starting from where we stopped. So that was, we were looking at discussing applications of, possible application of machine learning. So in which case we are following the route of taking clue from the past successful utilization or application, while trying to see how can we explore the present and future possibilities as day in, day out. So for some of us that might be conversant with the latest research world, even in startups, so people are taking to artificial intelligence, with machine learning be one of the major backbone of some of these applications, BU in the research, in the research, R&D, research and development centers, in the higher university, and also even in startups and businesses. So we try to see, we started by looking at some of the applications that we've been personally involved in at some of our teams, so that we can hopefully have even better insight to it, and why also encouraging each participant to try to see, okay, what can I make of this particular new technology from your individual's point of view of their own specialization? Because I know we have people from medical, we have from the engineering in general, which are very diverse, the material, nano, mechanical, civil, and so on and so forth. So that was what we started maybe 2 weeks before we went for the break. So we are going to continue. If I remember vividly, we were discussing some of the application in this sense, whereby we mentioned successful applications that we and my team were involved in. So I was cited, we discussed oil and gas. I remember we mentioned the application of nanomaterials characterization. Specifically, we were to discuss it when we stopped for that day. So we're going to continue from here, looking at the magnetic refrigeration, that is the alternative energy sources. So we did several work in this area using machine learning, the standard one, and also hybrid ensembles, to see how can we model some of these materials, so that when it comes to production side or developing this kind of product, it could become even faster, and also we could even assist them to be able to come up with even more better material. So under the, of course, the material science, also we had a lot of things to do there. So we work extensively when we are still doing that. So on the material science, the band gap and engineering of materials used in energy conversion, so that it's not just to generate the energy. Sometimes you have to convert from one area to the other. The engineer knows better. So we did modeling using machine learning. We also have the superconductivity area, where we try to look at how can we use machine learning to predict the persistency of energy transmission with zero energy loss. So when we generate energy, like everybody is talking of alternative energy these days, so it's not just to generate the alternative energy, you need to be able to store it. Sometimes, yeah, so transferring it from one point to another also is an issue. So a lot of interest in trying to have material that will have near zero or with very, very low energy loss during the transmission process. So some of people actually contacted us on this, invited us with data. We did some things in this area, which we hope we have the opportunity to look into in detail one after the other later on. We've also had the opportunity of working on membrane technology. So I remember one of it was to see the permeability of materials through things that we ordinarily think that they are not permeable. For example, we all know when you put nylon, you put oil inside nylon, after some time, you see that the oil will find its way out of that nylon, even though it was generally, actually, it was a bit surprising to me also when I came to Nebodi's Technology. That was when I was invited to participate in this research work. So when I was invited to participate in this research work, then we got to know that the permeability of material, that the material will be able to percolate or pass through a particular medium, depend on the permeability of that particular medium and the characteristics of the material. So with special interest in oil and what we call polythene or nylon as a case study. So it was a very huge success when it comes to the outcome, what was achieved, and then took the paper, that the outcome of that work got actually acceptance in one of the very top journals in the area of chemical engineering as it relates to membrane technology. So we also delve in little into autonomous driving predictive solution, which we list some of them shortly. We had the AI in cybersecurity. We touched on ignition energy prediction. That is ignition energy prediction. That is every system or every compound or chemical, they are very useful ordinarily. So, however, we were made to study, okay, at what particular property or physical property or temperature or surrounding environment that can affect the point at which ignition system for ignition could actually be triggered. This actually went side by side with the one we call the explosive temperature estimation for industrial production and safety applications. So also a lot of works was done in this area that ordinarily in industrial production systems, you have chemicals that are being used for normal production, but then these chemicals need to be maintained at certain temperature. Beyond those temperatures, these useful chemicals will become explosive, which will be detrimental and dangerous to the industry. So in this case, we were focusing on trying to estimate at what temperature will a particular chemical at a particular environmental condition turns to devastating explosion. So knowing this means that we can have a real-life system that can monitor the production processes so that by the time before the temperature actually gets to that point, the machine learning system should have been able to raise an alarm so that necessary preventive measure will have to be put in place. So that was a short idea of what this kind of application actually dealt with. Now, moving forward also, we actually discussed the idea of machine learning modeling for construction applications. So no side is left. There's no field is left aside, actually, outside when it comes to the possible application of machine learning, except we are yet to really think deep about it and see how can we bring it on board. So in the ML modeling for construction applications, several work has been done in this area, and give it to one of our very hardworking brother who recently completed his PhD with special interest in this particular kind of area, and happened to supervise him with his main advisor. So we explore several possibilities, and the outcomes are really very overwhelming to the point that just maybe a couple of hours ago, I got to know that the brother has been awarded as the best graduating student for the sets of students in his university after completing the PhD. Because I was also very much impressed to like to share his story, because he happens to come from architectural, you can see from construction application. So he's as an architect, so from architectural engineering, but picked up interest in machine learning. And within 2.5 years, he was able to make a very great impact in his field, that some of his works now are being used as reference point for people who are interested in these areas. So some of the area we happen to explore together in that sense is construction delay mitigation models were built using different machine learning applications, the construction duration of tall building project estimation, the cost estimation model for tall buildings, so ML model for delay risk assessment in tall building projects. So it was a kind of several ideas when it comes to tall building, because tall building is becoming, the idea was kind of fascinating, because these days you see people start building tall buildings here and there because it has advantages of saving money, especially when you don't have enough land. So you can try to maximize the number of space you are going to have on a single plot. However, tall building has special problems in that, one, if you start a very tall building, it involves a lot of money. If you underestimate the cost that is going to be involved, then that building is likely going to suffer from abandonment. And you can see, go around and you see a lot of tall buildings that are abandoned. Because once you underestimate it, the difference between what you are going to need now to complete it is not something small, it's going to be huge. And then you might not be able to get financial institutions to support you after investing huge amount of money in that system. So there was a serious need for a system that can be able to provide near accurate or very accurate predictive solutions that can be able to tell them the idea of, okay, what do we need when it comes to estimating the cost, what is going to be involved in building this particular tall building. So sometimes delay is not just the fund only. A lot of things can also lead to delay. So delay mitigations are there. So the construction duration estimation, how long it's going to take, and also the cost estimation model. And finally, also the delay risk assessment were also carried out, all integrating appropriate machine learning technology. So it was indeed a very, very successful application area. And that was the first time personally I was involved in trying to see how machine learning can actually be explored when it comes to construction applications. And there's still so much work because that actually needs to be done. So for those people who might be interested in that area, so or who happen to come from those areas, civil engineers and host of others, I want to believe that a lot of applications, a lot of opportunities that are actually waiting for people to come and explore. So, and a lot of contracts, a lot of buildings, construction have suffered a lot because of lack of adequate, this kind of adequate solution that could have actually made their life very easier. So I want to believe people need to look in this direction. And personally, this is one of my research focus, actually. So that is a lot of things we can do, but making life easy for people. So people working in other fields who are not aware of machine learning, there are a lot of jobs, you spend a lot of time there. At the end of the day, it could fail. But with machine learning, based on our experience, we can actually assist people to do their work better. So this is one of my aim and objective as far as my research interest is involved, trying to solve people's problem. That is, let humanity benefit from this particular unique technology of AI and with special focus on machine learning, as the case may be. So going further, we also had the opportunity of looking into environmental pollution modeling. So we delved into that one also, try to see. So we look into modeling the environmental pollution. We even had the opportunity of working with especially the pollution even in water. So not just subsurface only. We had the opportunity of that, try to estimate some of the possible pollutants in water and what level and what can we do to predict and what can we actually do to salvage the situation. So we have several others also in biomedical applications. For example, in the estimation of the refractive index of oxygenated and deoxygenated hemoglobin, so trying to predict the refractive index. So as we go a long way to assist people in deciding what to do and what to not to do with a set of blood samples. So we also, in the diagnosis of selected diseases, more will come on this one later on. So this is, and this one goes together with what we call preemptive diagnosis of diseases. So diagnosis of disease is different from preemptive. So preemptive is a kind of maybe a kind of a patent idea presently under processing for us, whereby diagnosing is when you diagnose someone that is already having complaints. You see, so this is called diagnosis. It could be early diagnosis, that's fine, but he's already having some symptoms. But preemptive diagnosis is a system we're putting up that we're trying to see that, okay, why do we need to wait for people to be sick before we actually diagnose them? Because we have had several cases. So this idea was motivated by the fact we have several cases of people just complaining of little pain in some part of the body. On getting to the clinic, they will declare that, oh, this is late stage. We have seen several cases like that. Late stage cancer. We have had several cases like that. Oh, this is second stage of diabetes, and several cases like that. Because human body, subhanAllah, is so kind of built in such a way that we can withstand a lot of things. So many things going on in the body, but there's no pain, there's no complaint, you don't know. By the time the complaint comes in, halas, it's getting late. So the idea is, why do we need to wait? If we can use machine learning and AI to predict when there's going to be rain, sometimes it's come to be true. It could be rain. Of course, sometimes it might not. But with very high percentage of accuracy, in most cases, it's always correct. So if we use it for weather forecasting, so why don't we try to use it for monitoring human health? So that is the idea of this work, that we're taking diagnosis to people who are not sick. So because, and in reality, everybody is potentially having one or two things in their system, but it's gathering momentum. So we don't want it to gather enough momentum to strike the person before you actually detect it and say, oh, there's a possibility that, oh, this person might suffer from this. So we can take preemptive measures. See? So it's coming up with what we call proactive medicine. So a center is being organized at the medical center. Is going to be called proactive medicine. So that when we install this AI system, which is also kind of part of a potential startup we're working on. So we'll be able to integrate it to any clinic that is interested. So anybody that goes for medical laboratory checkup, let's say somebody is planning to travel out for his PhD or travel to anywhere for visa processing, you need to do some medical, some blood works. The moment your blood work is coming out, so it's automatically engaged with the AI that has been built to detect. At the beginning, we're targeting chronic diseases. So it will check the blood for possible chronic disease, one after the other, automatically. And if by chance, one of the chronic disease is alerted to be possibly present in the blood, then an alert will be sent to what we call the proactive medical care unit, that must have been provided with experienced psychologists, because you don't need to scare people. Experienced psychologists will come and talk to them. Oh, we will call the person involved. You came to our laboratory so day, so we want to see you. They talk to that person, trying to encourage him. You are not sick, but we have seen some things in your blood that shows that you might have some sign of so kind of disease. So we encourage you to follow with doctor now, earlier, so that they can give you some preemptive or proactive advice. Some people need to change their lifestyle at the early stage if they know this particular fact, rather than waiting till it is too late. So this is just a summary of this particular, is a very big idea, and several work has been done in this area. Lung cancer has been automated, glaucoma, working on glaucoma, kidney disease, diabetes, thyroid cancer. So one after the other, the system is being imbued with more and more chronic diseases, and the work still continues. So this is just an insight to us to think of some of these areas we are specializing, we are specialists in. What can you do? How can you bring in this kind of technology in your area of specialization that can hopefully increase productivity for your own system or save life for people? Because to me, I've seen a lot of potentials that we just need to explore together towards benefiting humanity. So, of course, we're also possibly also even creating jobs. But that's one of the benefits to humanity anyway. While you are trying to save life, you're also providing job for people. If you have startup from your system, people will be engaged, people will be employed. Like the example now, to our knowledge, there's no medical center that has this kind of a system. So psychologists will have to be employed in the proactive care center, and so many other employees that will have to be involved in one stage or the other. And this is the good thing about some of these particular applications, because they are coming on board, they are not there earlier, and a lot of opportunity for people that will benefit from it, and people from their health wise, and also people that benefit from getting job in that area. And I want to believe that lots of areas where these things also are, opportunities are there, but they are not being explored. So this is one of the essence of this kind of discussion. Now, so moving further, we look at the renewable energy prediction application. This is also another area that caught my attention specifically. So I had one that we call bidirectional energy predictive system. See, there are a lot of renewable energy. You want to predict the amount of energy that can be captured from the sunlight or from the wind energy in a particular country. Some people also sometimes try to predict the kind of the amount of energy that people need to use in their house. So the idea of this is that bidirectional is for effective energy utilization, we need to know the amount of energy needed, and then the amount that can be generated from a particular location. Then we can be able to plan that, okay, if there is excess, let's say from city A, we can only generate so amount of energy from the sunlight or wind, as the case may be. But the same city needs very small amount of energy for its consumption. We can plan ahead of time to see how can we direct it to other areas that need more but are generating lesser. So this is called bidirectional energy predictive system. So this idea was presented in one of the Saudi-British possible collaborative ideas 2-3 years ago, and work is going on also on this kind of application for patent possibility, inshallah. And then moving further, we also going to talk about the, before we move further, let me check. Okay, I think, yeah, permit me, maybe it's a good place to keep it, to call it, to keep it a stop so that we can also listen to you because of our time. The good thing, that unique thing about what we have discussed so far is that some of these applications, they are unique. Like I mentioned earlier, that this AI, the machine learning system is generic. You see, this is the good news. Something that will work for one might actually work for other. Of course, we have to check it out. There's no method that is always good in all situations. So which I usually refer to as let the data speak. Let the data speak. So once you use a system, When you have a new data, you try it out. Maybe it could work, but sometimes it might not work. You might need to come up with a modified algorithm, totally new algorithm. You might have to develop it. Or sometimes you might need to come up with my favorite, the one I call the cocktail, which is now ruling the world. I mean, it's becoming one of the very best method that people are always resorting to when you have difficult problem to solve. So we have talked about it before. You can check our videos archive. So ensemble is where you might have to mix 2 or more algorithms together to let them decide for you. So consistently now it has been proven to be the most sought after system of machine learning, because sometimes when you use individual algorithm for any of these applications, it works to some level and the performance gets stuck. It doesn't increase anymore. No matter what you do, you can't take it further. Then you try to bring in maybe 2, 3, 4, 5, 6, sometimes as many as possible models. Then you merge them together to decide. So this is what we call a cocktail. So in Arabic, we call it mushakkel. So you mix them together and it's becoming very, very effective. So some of the very popular competitions internationally, actually the winners are always resorting to ensemble application now. So like Kaggle, you have a lot of competition in Kaggle. So as we move on, for those who might be interested, I so much encourage people to try to participate in this competition. You can form groups. So sometimes you have a price tag of $1 million, $500,000 and scores on this particular, and the application you do right on your own computer in your house. Group can come together to try to work on it, to at least challenge themselves and challenge also people, and also contribute one way or the other to see how the world hopefully can become better from machine learning point of view or from AI application point of view. So this is what we are going to have for the day. So we are going to give opportunity for anybody to ask questions or comments regarding, okay, how do you think you can actually bring up your own area of application, and then trying to see, okay, how can you work on that? I think on that one, so before I drop the mic, I'm going to give us a kind of maybe an assignment for individuals to come up with at least 2 to 3 or 3 or more areas of possible application of machine learning that you can think of in your own area of specialization. Let me give it as an assignment for everybody. So once we are done, so you can send it to me, so or to the coordinator. So we don't need to share it in the platform. Later you share it in the platform, but when you have your own, send it to the coordinator and send it to me, so that at least 3 or more possible application areas that you can identify in your area of specialization. So thank you very much. So that is it for the day. So we move to question or comment section. Barakallahu fikum.